In this project, we are going to build a complete DevOps pipeline using Ansible and AWS. The main idea is very simple. Instead of doing everything manually, we automate the entire process from infrastructure setup to application deployment. First, we will provide the infrastructure on AWS. This means we will create cloud resources like AWS instances automatically. Next, we will configure a remote server using Ansible. No manual SSA, no manual installation, everything is defined in code. Then we deploy a simple web application, in this case, a basic HTML page. Even though it is simple, it represents how real applications are deployed. Finally, we verify everything through a browser. If we can access the web page successfully, this means the whole pipeline works end-to-end. The final goal is very important. We want full automation from infrastructure to application. This is the mindset of modern DevOps: repeatable, scalable, and reliable system. What you will learn. By the end of this project, you will gain several important DevOps skills. First, you will understand infrastructure as code, also known as IAC. This means we define infrastructure using code instead of clicking in a web console. Second, we will learn how to interact with AWS using Portal 3, which is a Python SDK. This allows Ansible to communicate directly with AWS services. Third, we will explore dynamic inventory. Instead of hard-coding server IP, Ansible can automatically discover running EC2 instances. This is extremely important in the work environment where servers are constantly changing. You will also learn how to configure servers automatically, for example, installing Nginx, starting service, and setting permission, all done by Ansible. Finally, you will understand a basic deployment workflow, which includes provisioning, configuration, deployment, and testing. All of the work for foundation of real-world DevOps practice. Even though this is a simple project, the concepts are exactly the same as in larger scale system. Architecture overview. Let's take a look at the overall architecture. We start from the local machine where Ansible is running. For there, Ansible communicates with the AWS API using Portal 3. This is how we create and manage cloud resources programmatically. Next, AWS provides an EC2 instances, typically running Ubuntu. After the instances is created, Ansible connects to it via SSA. This connection allows us to configure the server remotely. Then, we install Nginx with S as a web server. Finally, we deploy a custom HTML page which user can access through a browser. So the flow looks like this: local machine, then AWS API, then EC2, then Nginx, then HTML page. The key idea here is control and automation. Everything is triggered from one place, your local machine. This is a centralized and automated architecture, which is essential in DevOps. Project structure. Now let's explore how the project is organized. We have a main folder cons project, and inside it, an Ansible directory. This directory contains all the important files. First, we have a provision YAML. This playbook is responsible for creating infrastructure on AWS. Second, we have a configure YAML. This playbook handles server setup, such as installing Nginx and deploying the HTML file. Next, we have a inventory AWS EC2 YAML. This is our dynamic inventory configuration, which helps Ansible discover EC2 instance automatically. We also have a files folder, which contains the index.html files, our simple web application. Finally, group was /on YAML store share variables like Dragon, instance type, and AMI ID. This structure flow best practice separation of concern, reusability, easy maintenance. In real projects, having a clean structure is extremely important for scaling the teamwork. 3 requests setup requirement. Before running this project, we need to prepare our environment. First, install the required Python library, Bottle3, and Ansible. Then install the Ansible AWS collection using Ansible Galaxy collection command. Next, configure AWS Creator using AWS configure command. This step is critical because Ansible needs permission to interact with AWS. You will need access key, secret keys, default region. Also, make sure your IAM user have a permission to manage EC2 resources. If this step is not done correctly, the entire automation will fail. So, always double check your credentials and permission. Things of this as setting up the foundation before building the system. Variables configuration. Group was /on YAML. In this file, we define reusable variables. For example, AWS region, key pair name, instance type, AMI ID, security group name. Instead of writing these values directly inside the playbook, we centralize them here. Why is this important? First, is avoid hard coding values. If you want to train the instance type, you only update the once play. Second, is improve maintainability. Your codes become cleaner and easier to understand. Third, it makes scaling easier. You can reuse the same playbook across different environments like that, staging, and production. This is a standard DevOps practice called configuration management. It helps teams work faster and reduce errors. Provision playbook, provision infrastructure. Now let's talk about the provision process. In the provision YAML playbook, several things happen automatically. First, we create a security group. This defines what traffic is allowed to reach our servers. Then we open 2 important ports, port 22 for SSA, port 80 for HTTP. After that, we launch an EC2 instance using the defined configuration. Finally, we output the public IP address of the instance. The most important idea here is automation. We do not log into AWS console. We do not click button manually. Everything is defined in code and executed with a single command. This ensures consistency and saves a lot of time. In real-world systems, this approach is essential for managing large-scale infrastructure. Dynamic inventory. Traditionally, Ansible uses static inventory file where you manually define server IP. But in cloud environments, servers are dynamic. They can be created and destroyed at any time. This is where dynamic inventory comes in. Using the Amazon AWS EC2 plugin, Ansible can automatically discover EC2 instances. We define filters such as region and instance state. This means Ansible will only target active servers. The benefits are huge. No manual update, work well with scaling, reduce human error. That is exactly how modern DevOps team manage infrastructure. Dynamic inventory is a must-have skill for cloud environment. HTML test page. Simple web application. For this project, we deploy a very simple HTML page. It contains just one line, Ansible plus AWS deployment success. Even though it looks basic, it plays an important role. First, it helps us validate that deployment works. If we can see this page in a browser, everything is functioning correctly. Second, it simulates a real application. In real projects, this could be a front-end app, API, or microservice. Third, it verifies that engine is correctly installed and configured. Think of this HTML files as a deployment architecture. Think of this HTML file as a deployment artifact. In real DevOps pipeline, artifact could be Docker image, build files, compiler application. This step ensures that your system is not only running, but also delivering value. Configure playbook. Configure EC2. After provisioning, we move to the configuration phase. In the configure Jumbo playbook, we automate the server setup, but we install Nginx. This turns our EC2 instance into a web server. Next, we start the Nginx service and enable it to run on startup. Then we copy the HTML files for our local machine to the server. Finally, we set the correct file permissions. The key idea here is consistency. Every time you run this playbook, the server will be configured in exactly the same way. No manual step, no configuration drift. This is one of the biggest advantages of using Ansible. It entails reliability and reduces human mistake. DevOps flow. Let us summarize the entire workflow. We follow from main step: provision, then configure, then deploy, then test. Provision means creating infrastructure on AWS. Configure means setting up the server environment. Deploy means delivering the application. Test means verifying everything goes correctly. We can map each component. AWS represents infrastructure. EC2 represents the server. Nginx represents the running environment. HTML represents the application. This flow is exactly how real-world systems are built. Even larger companies follow the same principle, just at a bigger scale. The more important takeaway is automation plus consistency is a reliable system. Once you master this workflow, you are already thinking like a DevOps engineer. DevOps flow.